Hi everyone, today we are going to take up questions on Maclaurin series. We'll solve two questions. These questions are from IB past papers. Let's look at the question number 1. The function f is defined by fx is equal to product of two functions e raised to power x into sin x, where x is a real number. The question is, find the Maclaurin series for fx up to and including the x cube term. So let's answer first question, part A. So we'll use formula booklet. From the formula booklet, we are given the Maclaurin expansions of e raised to power x, that is 1 plus x over 1 factorial plus x square over 2 factorial and so on, and sin x is given x minus x cube by 3 factorial plus x 5 over 5 factorial and so on. Now we'll take the product of these two, e raised to power x into sin x. So e raised to power x 1 plus x over 1 factorial plus x squared over 2 factorial and so on times x minus x cube by 3 factorial plus x 5 over 5 factorial and so on. Now we multiply each term with the first expression in the bracket to get x cube, that is x, 1 with x cube, that is x cube by 3 factorial, x with x, that is x squared by 1 factorial, and then x squared by x, that is x cube by 2 factorial and so on. Then simplify x minus x plus x squared, x cube by 3 factorial, that will be x cube by 6 plus x cube by 2 and so on. So simplify, that will be x plus x square plus 1 by 3 x cube and so on. Now B part, let's look at the B part of the question. We have hence is a quantum, so means we have to use part A. So e raised to power x square into sin x square. So first we get the expression e raised to power x square into sine of x squared. So replace x by x squared in the part A. So that will be equal to x squared plus x squared whole square plus 1 by 3 x squared whole raised to power 3 and so on. And then simplify x squared, x raised to power 4, 1 by 3 x raised to power 6 and so on, step by step. Now coming back to the original question, definite integration e raised to power x square sine of x squared respect to x, because we have to integrate only up to 3 terms. So we integrate the right hand side of the above expression between the limits 0 to 1, x squared plus x raised to power 4 plus 1 by 3 x raised to power 6, and that is equal to x cube by 3, x5 by 5 and x7 by 21, limits 0 to 1, plug in the limits. So that will be 1 cube by 3, 1 5 by 5 plus, we can skip that step also, minus 0, all of the terms will become 0, and when you simplify, so that will lead us to 61 divided by 105. So our second question is, write down the first 3 terms of the binomial expansion of 1 plus t whole raised to power negative 1 in ascending powers of t. We know that The Maclaurin expansion for 1 plus x raised to power p is 1 plus px over 1 factorial p into p minus 1 by 2 factorial into x square and so on. Now here x is equal to t and p is equal to -1, so that will give us 1 plus t raised to power negative. First three terms, so we just plug in p -1, we'll get 1 negative t, and here 2 and 2 factorial will get cancelled and we'll get t square. So first three terms, that's the answer to part A. Answer to part B. By using Maclaurin series for cos x and result from part A, show that the Maclaurin series for secant x up to and including the term in x raised to power 4 is 1 plus x squared by 2 plus 5x4 by 24. So in second part, we have to use part A. So secant x is reciprocal of cos. So if we see 1 plus t raised to power -1, that is 1 over 1 plus t. So therefore we can take 1 plus t is equal to cos x. Therefore t is equal to cos x minus 1. And we plug in this in the part A. So therefore 1 plus t raised to power -1 is equal to 1 minus cos x minus 1 plus cos x minus 1 whole square. Left hand side is secant x because we already have seen it over here. Since Maclaurin expansion of cos x from the formula booklet is 1 minus x squared by 2 factorial plus x4 by 4 factorial and so on. So we plug in 1 plus t raised to power -1 is nothing but that is secant. So secant x is equal to 1 minus x squared by 2 factorial x4 by 4 factorial and so on minus 1 minus x squared by 2 factorial plus x4 by 4 factorial and so on minus 1 whole square. 1 and 1 will get cancelled, 1 and 1 will get cancelled, so that's equal to 1 plus x squared by 2 factorial minus x4 by 4 factorial is 24 and so on, plus the second brackets that will come out to be minus sign, that is x squared by 2 factorial is 2. Oh, we have to square that, plus sign, so x4 by 4, 2 factorial is 2, so 2 square is 4, and other terms we do not need to square because we need only up to x4 and so on. So we squared only the first term of the second expression. That's equal to 1 plus x squared by 2 minus x4 by 24 plus x4 by 4 and so on. When we simplify, that will lead us to 1 plus x squared by 2, and that will be 5 x4 by 24. So that's the answer to part B. Thank you.